Okay, welcome everybody. This is 15.6 properties of parallelograms. And so we know how a parallelogram looks, right? It's a quadrilateral, four sides. And here are the properties. The first property is that opposite sides are parallel. So remember how to draw out on the picture itself how it's parallel, these little arrow marks, right? So opposite sides are parallel, and then opposite sides are congruent. So they are parallel and congruent. So remember, these little tick marks signifies that they are congruent. Okay. Third one, opposite angles are congruent. So here, this angle is congruent to this angle, and this angle here is congruent to this angle here. Okay. Check. And then the last one, that the diagonals bisect each other. So if we have diagonals, remember, it's a segment that connects opposite vertices. Okay, so there's my diagonals, right? And they bisect each other. So that means that AC bisects BD. So these guys, let me go with 3, 4, are congruent, and BD bisects AC, meaning that these guys are also congruent. Okay, so there's a lot of things going on here. These are the properties, and let's actually write out what that means. So opposite sides are parallel. That means AB is parallel. Remember, the symbol for parallel looks like just 2 vertical lines to DC, and AD is parallel to BC, right? Opposite sides are congruent. That means AB is also congruent to DC, and AD is congruent to BC. Okay. Opposite angles are congruent. That means that angle A is congruent to angle C, and angle B is congruent to angle D. Okay, the diagonals bisecting each other. Let's actually put a point right in the middle. E. If they bisect each other, that means that AE is congruent to CE, and BE and DE are also congruent. Okay. So there are my properties of parallelograms. All right. And later down the line, we're gonna be dealing with special parallelograms, but this is your foundation for parallelograms. Okay. Questions? So with that in hand, we are going to be solving some problems and doing some examples. Okay. So we have to find the values of X and Y. Here we have 5X plus 19, and here we have 7X. Okay, just looking at the sides for now. What do we know about opposite sides? They're congruent to each other. So all we do, class, is we're going to go 7x equals 5x plus 19. Set them equal to each other because the side lengths are equal to each other, right? And then do some basic algebra. Subtract 5x on both sides. We have 2x equals 19. Divide by 2, divide by 2. X is equal to 19 halves. If you guys put that in decimal, it'll be 9.5. Okay. Cool. If we solve for y, what do we know about opposite angles? They're congruent. So again, we are going to go 6y plus 5. Since opposite angles are congruent, we're just going to make them congruent to each other. Equals 8y minus 17. And then I'm going to just solve it. Subtract 8y. I'm going to subtract 5. By doing this, I kill 2 birds with 1 stone. Take out the 5. Take out the 8y. And we're left with negative 2y is equal to negative 22. Divide by negative 2 on both sides. Y is then equal to positive 11. Right? Whoa. Okay. And with both in hand, if I ask you, or if the question asks you for the length of BC, or the length of AD, or even angle B or angle D, you guys are able to do it by just plugging it in, right? You just plug back in X or Y back into the expression, you're able to find that value. Okay, cool. Next one. Okay. Now here we have to actually find that value, right? So X plus 9 is this guy here. And 4x minus 6 is actually this guy here. Right? What do we know about those two segments? They're equal to each other, right? So if they are equal to each other, then we can make them equal to each other. So x plus 9 equals 4x minus 6. And we're going to go ahead and solve. I'm going to subtract x. I'm going to add 6. Okay, again, killing 2 birds with 1 stone. Doing that would eliminate the x from my left-hand side and eliminate the 6 from my right-hand side. So we have 9 plus 6 is 15 equals 4x minus x is 3x. Divide by 3, divide by 3. X then would equal 5. Right? If x is 5, then PT, which equals x plus 9, is actually 5 plus 9. So PT is 14. Okay. Do I have to plug in X for TR as well. Because I'm trying to get PT, right? PR, I mean. I'm trying to get PR here. Correct? That's what I'm doing for number 9. Now, do I have to go and get RT, that value? Why? What do you know what RT is already? Without plugging it in. I can literally go 4x minus 6, 4 times 5 minus 6, which is 20 minus 6, which is 14. Well, we already know it's 14, right? Because we got PT, and they're congruent to each other. So we could just multiply it by 2 and get 28. Yeah. Okay, so that's number 9. To get QR, which is this here, I have to solve for Z. Opposite sides are congruent. So I'm going to go 3Z minus 4 is equal to 2Z plus 4. So then I'm going to subtract 2x or 2Z, I'm sorry. This should be Z. Subtract 2Z and add 4 to both sides. Again, doing that would cancel out this 4, cancel out the 2Z. So we have 3Z minus 2Z, which is Z, equals 4 plus 4, which is 8. So if Z is 8, then 2Z, then PS, or you know what, QR, which is 3Z minus 4, would be 3 times 8 minus 4, 24 minus 4, which is 20. Because that's the size of PS. Yeah. So opposite sides are congruent. So I made those two guys congruent to each other. Cool? Questions? Simple? Okay. I'll give you guys 2 minutes to try this out. So these are your answers for these problems. And moving on. Now we get to proofs. Okay, we have 3 of them. Maybe I'll just go over one today because I just want to introduce it. And maybe on another video, we will talk more about it. Okay. So in terms of proving, just like how we proved parallel lines, right? We proved in terms of parallel lines, we proved that one of the 5 different angle relationships existed, correct? And therefore I can say that those 2 lines are parallel, correct? This is the same way. Okay, we're going to prove that one of the 4 properties exist. Therefore, I can say that this is a parallelogram. This quadrilateral is a parallelogram. Okay. So if we list it out, ways to prove a quadrilateral is a parallelogram. Okay. First way, show that opposite sides are congruent. Yeah. Second way, show that opposite sides are parallel. I forgot one key word for both. Both pairs of opposite sides. Okay. Both pairs of opposite sides are congruent, are parallel. The third way is show that one pair of opposite sides are congruent and parallel. Okay, so if one pair is both congruent and parallel, then we show that it's a quadrilateral. The fourth way, show that both pairs of opposite angles are congruent. And then the fifth way, show that the diagonals bisect each other. Okay? Those are the 5 ways to prove a quadrilateral is a parallelogram. All right, it's essentially just telling us that one of the properties exists, right? So before I even jump to the statements and reasons here, actually, these are not proving that the quadrilateral is a parallelogram. We're using the properties of parallelograms to prove something. So this one here, I gotta prove that angle G is congruent to angle L. Okay, I don't know how yet, but I know that's gonna be my last step, right? I know that this is gonna be the given that G, H, J, and J, K, L, M are P grams. Okay. How do I prove that this angle is congruent to this angle? I know that those quadrilaterals right there are they're parallelograms. Take about 15 seconds to prove it without writing it. Okay, just prove it in your head. Oh, they are congruent because blah, 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 blah. Okay. If opposite angles are congruent, then I know angle G is congruent to angle HJN, and angle L is congruent to KJM, right? Now what? they're vertical angles. These inner angles are vertical angles. So I know that they're congruent, so I'm just gonna add another line right there. So they're vertical. And since that's angle HJN are two angle measures that I drew, this one's also gonna be 2, correct? So through what property do I know that angle G is congruent to angle L? Yeah, it's transitive, right? So does everyone understand the proof? Yeah? Okay. So the second step, I would write that angle G is congruent. Honestly, class, I'm gonna put a number here, okay? And you guys can mark it up. Mark up the proof, like how I did, right? And number the proof, like how I did, number the angle. Because I can, down here, when I write it down, I can just say angle 2 instead of saying angle HJN, okay? And angle L is congruent to angle 3 because opposite angles of a p-gram are congruent. Yeah. And then step 3, angle 2 is congruent to angle 3 because they're vertical angles, and vertical angles are congruent. And this would be your step 4. And this would be through transitive property. Cool? Questions? Yeah, so we're just using our properties of parallelograms to figure out the proof. Okay? That is the lesson for today. Okay, that is the lesson on 15.6, properties of parallelograms. Thank you.